So a particle which is moving in a magnetic field will receive a force which is given as Q V cross B. And well, if we have a magnetic field and a particle which has a velocity, the force which is going to be received to the particle is always perpendicular to this vector velocity and vector magnetic field, always perpendicular, right? So what does that mean? So if we have a magnetic field that is pointing towards the inwards of the screen, and then there is a particle which is moving, for instance, with a velocity that is towards this direction, then the force that is going to be exerted towards this particle moves downwards. Try to do it with your right hand rule. And since it receives a force, well, the trajectory of this guy will start to move towards towards a direction that is something like this. If we try to simulate what happens to this guy later on, well, it will have a velocity towards this direction, and this will exert a force that goes towards this direction. So this will go towards the inwards, and the motion of the particle will continue like this, and it will have a circular motion. So the magnetic force is being a centripetal force. Let's remember a little bit about that. So if this is a centripetal force, then it means that it is equal to the mass of the particle times the centripetal acceleration, which is given by the tangential velocity over the radius, being the radius, for instance, the radius of the circular motion. And if that is true, and the magnitude of this is Q V times B, being the velocity perpendicular to the magnetic field, and only the perpendicular velocity, that is, or the component of the velocity that are perpendicular to the magnetic field, this is going to be equal to mass velocity squared over radius. And if we solve, for instance, for radius, this is going to be equal to m b squared over q times v, and this is m b over q, and I am using a magnetic field here, b, right? So the radius is mv over qb, and of course if we input the mass in kilograms, the velocity in meters per second, and the charge in coulombs, and the magnetic field in Tesla, this, although you might not get it directly, but this is given in meters.